we're having a session now on sustainable development where AI is going to be accelerating it. So with this, I would like to invite Praful Kulkarni. He is going to be moderating the session on use of AI in sustainable development. Praful is IIT Kharagpur alumni, also a past Penn IIT chair. He is currently serving as a director of CannonDesign, which is an architectural firm doing billions of dollars of projects on universities, campuses, and hospitals. He is considered as expert on green building, sustainability. So it's amazing to have Praful and his team of panel members giving us insight on the AI use in sustainable development. Please help me welcome Praful Kulkarni.
Thank you, sir. Leo. Well, hello, everyone. Can you hear me? Perfect. Sustainability is a topic that is near and dear to my heart as an architect. Estimates are 30+% of all the greenhouse emissions come from construction materials, and actual construction. So what we are going to talk about is how does AI affect sustainability going forward, and how we can come to a point where we create environments that are sustainable. The American Institute of Architects has a goal to be zero neutral. So zero, the 2030 pledge AIA has, where we design and build buildings that would be basically carbon neutral. So let me introduce my panel, which is well-versed in this area. First of all, Ramanan, an old friend. He's a globally recognized expert in sustainability, ESG, and CSR. He's the co-founder and chief scientific officer at ImpactEdge. He has over 4 decades of experience in teaching, so academics, and large firms like ExxonMobil, AECOM, and ICF. And he actually taught at Illinois Tech in Chicago in this space, and he's authored several books. He's also engaged with the Wheels Global Foundation. To his left is Marco Leone, and Marco is currently a vice president of applications engineering at Caterpillar Digital, which delivers industry-leading digital solutions to support Caterpillar and its customers all over the world. He has more than 2 decades of experience working for Solar Turbines, Caterpillar, including roles in design, field engineering, product support, and management. And then we have Professor Rao. Dr. Rao is a director of Qualcomm Institute and a distinguished professor of electrical and computer engineering at UC San Diego. Has been a pivotal figure in telecommunications and information technology. He has led numerous interdisciplinary research initiatives and collaborative projects. So the way we are going to do this is there are themes that 3 of my friends are going to talk about. And then there are a couple of questions that we can ask, and obviously your questions are entertained, but we are a little tight on time. As you know, we're running a little late. But we'll try and make this as informal and informative as possible. So with that, Ram.
Thank you very much, Praful. Okay. I don't think I really need a mic. Usually, being a professor, I could speak and my voice carries. But I'll go ahead and use. I probably am mic'd up. You all can hear me, right? Yes. I wanted to set a little bit of context on what sustainability is. When do you think sustainability started? 10 years ago, 15 years ago, 20 years ago, 100 years ago? How about that? To just set the context for you, vision. Gandhi said, avoid greed. Einstein said, use technology for good. And both happened in 20th century. Any reason? Yeah, the Anthropocene age, where planet and people were getting pummeled for profits. That's what needs to change. Slowly but steadily, economy has moved from only shareholders to all stakeholders. That is sustainability in brief for you. The actual definition is balancing today's needs while preserving resources for future needs. And there are 4 P's in sustainability: profit, people, planet, and purpose. And guess what? I have a different expansion of AI. I call it the avatar incarnate for our progeny. AI can make that change. It is the avatar that we need that can actually make sustainability happen. The next slide is a little crowded, and I'm not going to discuss each and every one of them. I'm just going to give you a glimpse of a few. But I want you to please recognize AI largely has 3 major components that it can contribute towards sustainability. It can talk about getting insights, gaining productivity, and monitoring action. For instance, we heard a few minutes ago about how you can accelerate material discovery by stimulating and predicting sustainability. So instead of just health area, you now have sustainability area. Likewise, if you are dealing with circular economy, something you all have heard of, it can identify reuse opportunities. Sustainability has a broad range of things it is capable of accomplishing, and those things will require AI. And somebody said earlier, don't take AI to the problem, bring AI to the problem that you have. With that, I'm going to pass it on to Praful.
Thanks, Ram. Now the next theme is going to come from Marco.
Great introduction. That'll be a tough one to follow up. I thought I'd step a little bit back. I actually live in San Diego, 19 miles as a bird will fly east of here. We have 2 acres, 3 kids, 3 dogs, 3 cats. It's a zoo at our house.
And nobody's eating them.
None of that is happening, but there are snakes and coyotes, so there is some of that happening by the wildlife. But a couple of years ago, when there were fires, and knock on wood, we are not in that same mode, the electricity went out a lot. And all of a sudden, you don't have a refrigerator that's working, your air conditioning's off, or at this time it was the summer, so that's a bigger deal. You wake up in the morning and you can't make coffee, tea, the oven doesn't work, the microwave doesn't work. I mean, you can't get water. I mean, it just brings you back to the state of a lot of the world that, they don't have, the modern ways of living that we do. And when I think you realize that, when you get put in a situation like that. So to me, it just put everything in perspective of, we have very first world problems. And again, we do need to obviously save, the planet. But when people are faced with just surviving and eating and having the basic needs for their families, it's a very interesting problem. So that leads me into Caterpillar. So I'm proud to work for Caterpillar, which coming up now next year for 100 years has been helping our customers around the world build a better and more sustainable planet. I mean, that's in our, that's basically core to our premise of what Caterpillar is there to do. We have products in the resource space, so you think mining, and right away you think, oh, that's bad. You guys are mining the Earth's resources, but things like batteries, those need to be mined. Solar panels, those don't just come out of out of the sky. They need raw materials. So resource industries is a big area of focus and a huge opportunity for sustainability with electrification and wind and solar and other sources of energy. Construction industries, so how do we bring the water, the infrastructure, the buildings, all the things the planet needs to evolve, but how do we do that in a more sustainable way? And I'll talk a little more maybe in some of the Q&A. And then energy and transportation, so Solar Turbines builds land-based jet engines. UCSD, for example, the campus, is powered by 2 of our machines. They provide the electricity and heat and steam for the heating and cooling, and the efficiencies of a cogeneration system like that are very high. So that brings me from my personal life to Caterpillar to now, why is this guy up here talking about digital and AI? So in the last 2 years, I've been focused at Caterpillar on building products and solutions for our customers in the software engineering space. So things from e-commerce to equipment management to condition monitoring to all the different digital tools that our customers and dealers around the world use. And AI is changing the game, and Gen AI is even taking it to the next level. And I can talk about some of those examples when we get into it. But that's just a quick intro, and I'll hand it over to Ramesh.
Thank you. Ramesh?
Thank you very much. My name is Ramesh Rao. I am a professor at UC San Diego, but I wanted to share 2 stories. One that takes me back to my childhood years, growing up in a small company town called Sindri, where the Fertilizer Corporation of India used to produce fertilizers. And so everybody we knew was immersed in the fertilizer industry, and I was shocked the other day when I looked up the carbon footprint of a loaf of bread. A loaf of bread which weighs 800 grams, let's say, has a carbon footprint of about 600 grams, right? That's how much CO2 goes up in the atmosphere for each loaf of bread. And about 40% of that is because of the urea that you use to fertilize the wheat crop. And the reason urea has such a large carbon footprint is because of the process by which you make ammonia, which Krishnamurti Mama, who used to live next door, was the plant manager for. How did they make ammonia? They liquefied nitrogen. They literally compressed and released and turned nitrogen from the atmosphere into liquid nitrogen. And water gas, you heated coal, which was very cheap in Bihar, and you blew water at it, steam at it. And that's how you produced hydrogen, and you combined hydrogen and nitrogen like in a chemistry textbook to produce ammonia, right? One of the most inefficient processes. And so what people are trying to do today using AI is to invent new catalysts that will allow you to produce ammonia without the high temperatures and the high pressures that are needed to produce nitrogen in the way in which we currently do it. So you need AI to be able to figure out new catalysts. That itself is energy intensive, right? AI is not energy efficient. The methods that you use are inherently energy intensive. So to reduce the carbon footprint of a loaf of bread, you might be competing for the same source of energy to figure out how to do it. So let's fast forward to stuff that we do at the Qualcomm Institute, UC San Diego. By the way, if you don't already know it, obviously, all of us at UCSD are most thankful to IIT Kharagpur for giving us Pradeep. He has wrought enormous change and transformation at UCSD. One of those things that has a societal implication is wildfires. So I don't know if you know this. I don't want to misquote, but since many of you live here in California, in the wildfires in California in 2020 released 127 million metric tons of carbon dioxide into the atmosphere. And over the previous 18 years, all the measures we took for sustainability saved us 65. So we saved 65 million tons over 18 years and put back 127 in 1 year, okay? So fighting wildfires is a way in which you can address sustainability in California. And we have projects statewide at UCSD which monitors using camera feeds, 1,000 cameras that watch the state. And what you're trying to do is using AI techniques, detect the onset of a fire before it becomes a conflagration, right? So you can put it up. To train those AI algorithms to be able to do plume detection is not energy efficient, right? So once again, do you use the power to learn how to put CO2 in the environment to learn how to not put back CO2 in the environment, right? There is this circularity. And in many ways, as academics and researchers, we love this kind of a challenge, right? Like, there isn't a simple answer. You don't just keep marching down a straight line. So lots more that we could talk about through conversations that might unfold.
Yeah, I mean, this is the issue that we really face. I mean, not only, as I talked about construction, and then you got the AI energy needs in themselves, and then the raw materials. I mean, it's a large issue. A couple of questions that I would like to start with, and we'll start with Ram. Ram, is AI critical to address climate policy issues? Global frameworks?
Largely talking about the public, the policy issues, right? Yeah. Actually, that's a very relevant question for many of us here. We heard a lot about policy this morning. We heard policy even in the pharma and on almost everything that we do. Many of you may or may not be fully aware of what's called externality. Externality is if one of them produces, somebody else uses, and if the interaction is only between the two of them, the third unfortunate individual that lives near the production facility suffers all the consequences. That is externality in brief for you. So there was a very, very relevant statement made by Sundar Pichai of Google. He said, he didn't say the first sentence that I say, and then I will tell you what he said. Sustainability is a mammoth shift in mindset, is what I say. And what he said is, AI is like climate change. We all share one planet. That is also true for AI. Both need guardrails. And that's what I mean by the externality. So if you don't have public policy addressing this issue, and now the public policy itself has become so massive and so many data points across the globe, it's a global issue, across the globe have to be brought together. Who but AI can do it? That's my response here for you.
So, Marco, what does the energy transition mean for Caterpillar's business?
Yeah, I talked about it briefly, but I think Caterpillar's in a great position to support the energy transition for our customers. As I mentioned, as we need more batteries for electrification, we need to provide those commodities in a more sustainable way, and we're investing heavily to do that. So even just having electrified equipment in the mines, and think of how important that is for the workers in the mines, but also just for the overall sustainability of the operation. In the energy and transportation space, really investing in alternative fuels. So obviously from coal to natural gas has been a big shift, but how do we get to hydrogen, and investing so that our machines and engines can run off of hydrogen, obviously assuming we source the hydrogen in a green way, but a lot of R&D and investments in being able to run on those better fuels. And then in the construction space, how do we do things like autonomy, and how do we optimize the operations of our equipment? How do we avoid equipment having to idle and be down? And that's where a lot of the AI that we're generating in my area specifically is, how do we avoid downtime? How do we move from time-based to condition-based maintenance? How do we predict issues? In this case, it's machine issues, unlike wildfires, but obviously a similar concept. How do we predict those issues before they cause inefficiencies? But it comes back to that, and I struggle myself of, I think the number, and I don't want to misquote it, but the number of data centers that are going in every day around the world is, I think it's like one data center a day. it's just mind-blowing. And the amount of energy that gets put into building that data center. And then Caterpillar's making a ton of money right now on all the backup generators. So if the electricity goes out, you need backup Caterpillar diesel engines to provide power to keep the data center running. And obviously that's not a great scenario to be in. But just all the energy that goes into the data centers to do the things that we're talking about, to avoid, it is a bit of a...
it's a dichotomy.
It's a dichotomy, and it's something that I think we really need to, and I think the guardrails and how do we kind of step back and really look at that trade-off and make better decisions. It's going to be a very interesting problem for us to solve.
And we thought crypto was really an energy hog. This is good. This is a whole different element in terms of just the size of it. Ramesh, can agricultural operations and data centers be engineered together? This is really something. I'm very curious to see how that comes out.
It's an interesting thing. When you confront something really challenging, you're forced to revisit your underlying assumptions, right? So it was interesting to hear your take on data centers. If you kind of do a back-of-the-envelope computation on what drives the economics of data centers, it's basically the energy cost. Your one-time capital expenditures wash out within 5 or 6 years. It hardly matters how much you put into it. What matters is the cost of the electricity that you consume. And yes, you're computing, but at a certain other level, all the energy this data center consumes gets turned into heat. And that heat has to be removed. So you need air conditioning to remove that heat. What if you could use that heat for a gainful purpose as opposed to just treating it as waste heat, right? Is there a way in which you could, for example, harvest it for agriculture, greenhouses, right? One of the expenses in a greenhouse is heat. So you can imagine, to get a little nerdish, co-optimizing agricultural systems and data centers, right? We traditionally don't do this. And what it will take for us to do it is to have people who know how to understand both these processes, right? The mechanics of what goes on, how plants actually grow, what their energy needs are, what their light needs are, what their sensitivities are, and figure out what is it about a data center that allows you. If you drive on 5, forget technical approaches to it, you drive on 5, you see what used to be almond orchards that have been raised and turned into photovoltaic farms, right? So man-made systems and natural systems both trying to harvest solar energy and turn it into something useful, right? Can't we co-engineer this? I think the answer is yes, but I think it requires a deeper dive into things that have traditionally lived in very different worlds. If I might use the UC as an example, we have 10 UC campuses. Only 2 of the 10 UC campuses have a strong agriculture focus, UC Davis and UC Riverside. All the other UCs kind of moved on, but we need to revisit.
So I'm going to have one more question for each, and we have about 8 minutes and 43 seconds. So the question, and then I'm not seeing any questions here on my, so we'll come back to you, sir. So lightning answers or lightning questions, however you want to put it. So Ram, how can AI help address the issue with greenwashing?
How many of you have heard the term greenwashing? Lift of hands. It's very simply speaking, not meeting your claims. You make a claim, and if you don't keep up, you are greenwashing the recipient. They can be funds that say, oh, our funds are so great, it's really going to save the planet, it's going to save the world, all of your kids, etc. And then you go ahead and invest in all of the things which are not going to do it. That is greenwashing. And how can greenwashing be addressed? It really needs a combination of technologies. And one such technology, which many of you are aware and has a little bit of infamy attached to it, is blockchain with crypto. But blockchain has a capacity to be immutable. The immutability of blockchain is a very useful property if you're able to collect your data with evidence, and which is trackable, traceable, and immutable. Thereby, you put it into a blockchain. It can't be really, you can't mess with it to start with. Now, there is the other end of it. You keep collecting data. You keep collecting data. We talk about, oh yeah, do they have the right HR policy for avoiding forced labor? You get about 100,000 documents because that's the number of suppliers you have. Can you really check humanly? Is it possible? Heck no. The way you do that is apply AI to extract relevant information and thereby use it for addressing things like greenwashing.
Thank you. Marco, how does AI and sustainability fit into Caterpillar's digital roadmap?
I'm going to flip it again, a bit of two quick answers. On the iron side, the circular economy and a big thrust for Caterpillar has been remanufacturing. So for many, many years now, I think before even it was a cool thing to do, but it was a profitable thing, we've been remanufacturing engines, machines, and it's really a triple win. It's a win for the planet, it's a win for our customers, and it's a win for Caterpillar. So a huge focus on that remanufacturing to avoid having to need new materials and new energy to meet the needs of our customers. But back to digital and AI, one of the apps we just launched into production, leveraging Gen AI, is to help our condition monitoring analysts. So these are people that are watching the equipment and making sure it's running optimally. They were having to do these recommendations by hand. They'd see a fault code from the machine. We have 1.5 million connected assets around the world that they're monitoring. They were doing all this manually. Now, when that fault code comes in, we're able to automatically provide recommendations to augment what the human, was having to do manually. So just a small example, but you can think of how much more we can use our carbon-based analytics to do versus, some of the more manual things that AI can do today. So much more to come, but I think those are just two examples of really how we can leverage, how business and what Caterpillar does can help from a sustainability perspective, bringing in AI as well. So Ramesh?
Ramesh, we have our discussion earlier. There was one question that we were going to talk about, and there's a similar question coming from the audience. It's directed to you. So you're going to talk about what tools or techniques will help develop new ways to jointly power AI and agriculture, and associated with that, can physics-based simulations augment AI for energy-efficient AI?
Absolutely, absolutely. A great question. To a room full of engineers in the limited time that we have, I think we need to develop new design automation tools that don't just simulate electrical principles, but heat transfer, photosynthesis, chemical processes, right? So you want to be able to come up with tools that will allow and make it readily accessible to large numbers of people, including farmers with small farms, to figure out how to integrate these elements. And I think this is a big topic, but very briefly, I think using physics-based or chemistry-based or biology-based models is a way to make AI more efficient, as opposed to just gathering lots and lots of data when you have no understanding of the underlying principles.
That's great. The other question is from the audience. The low carbon economy, wind, solar, et cetera, is destabilizing the energy grid. Storage is expensive. Demand management is not scaling. So this is the general question to all three of you, and you could answer it from your perspectives. So what's the solution?
The question relates to the energy balance of the globe, energy availability and balance for the globe to maintain our current level and yet meeting the future levels.
And also scaling, right? Yeah.
As we are injecting carbon-free technologies into the grid, solar, wind, EVs, the grid is becoming unstable. Solar energy storage is very expensive, and demand management is not scaled, it's not popular. So how do you stabilize the grid? Because the electricity grid is the foundation of modern civilization. how do we stabilize the grid as we go towards low carbon economies?
Yeah.
Low carbon technology.
It's a very good question, but I'm going to refer to my grandbaby. My grandbaby said, Grandpa, my teacher says if something is hard, you have to work harder. Find a solution to it. That's just to kind of, it's relevant there. It's a good question, but that's the relevance there. And what is really happening is there are tons and tons of innovations, and I always tell people, oh, I'm sustainable, therefore I should be seeing all the profits flow in. That doesn't happen that way. If you want to take benefit of sustainability, you will have to do some real serious innovation and experience the step change in your processes that will result in you. It's essentially a longer term thought process. Now, what is happening with regard to energy? Multiple things are happening, and that is why I talked about the guardrails on a very massive scale. You have situations where they are talking about applying land distribution for forestation versus agriculture using AI so that we can get sufficient carbon credits to address issues. They have technology today that is actually capturing carbon that is already left out there in the atmosphere to bring it down. Now, can we just quickly flip a switch and stop fossil fuel and go into something? No, we cannot do that. I'll just, a slightly politically insensitive comment I will make right now, and that is if any of you heard the debate, there was a reference to see what Germany did. They were thinking they're not going to use fossil fuel anymore, or they are all having to go back to that. No, Germany very quickly responded to that candidate and said, no, we are not. Germany is going very, very heavily towards other forms of energy. Now, do we have a solution in place? No. Other solutions, for example, hydrogen. Hydrogen is a phenomenal solution. No question about it. Geothermal energy, direct air capture, CCS, where ExxonMobil has put $1 billion, and one of the IITians is making millions out of it is Aniruddha Sharma. There are lots and lots of such innovations taking all over. It is not a flip of a switch. It's going to happen because of some very serious innovation. If people are thinking of doing and accomplish something of that nature, today, we are very well positioned to do that, especially the IIT engineers and the R&D.
Anything to add here?
So very quickly, in the limited amount of time, reason for optimism is look at telecommunications. You know, we could barely do kilobits per second, and today you can do gigabits per second to your phone. And partly what you're doing is adapting to the environment. So yes, the demand is stochastic, the supply is stochastic. You need finer control algorithms that can operate on a finer and finer scale. The reason for some pessimism is that the grid is relatively ancient, right? It is not designed in a way that allows you to activate it and do load balancing at the fine scales that you might need to. So there might have to be some significant investments that have to be done to modernize the grid. But in terms of the core technology, it's new control algorithms and being able to anticipate these fluctuations. People have solved this problem in much more challenging environments like wireless communications.
One small example in my previous life at Solar, in Western Australia, there's a tissue plant. They make toilet paper. And they use a land-based jet engine to provide the energy, the electrical energy, and then also the heat for steam for the tissue production. But that area of Australia also has a lot of wind and solar. And so we actually developed an algorithm, in digital to help them optimize when they need to run the gas turbine or when they can use the energy from the grid. And based on the pricing and availability and all sorts of factors, weather, the demand from the plant, but we were able to help them basically optimize their operation, save money, reduce their carbon footprint, because when the wind is blowing and the sun's out, they don't need to run the machine. So actually, at a small scale, I think, how do we do more of that? And maybe it's more of microgrids and having that smaller system to be able to optimize that could help us in the long term.
Priyank, are we done? Or how do you want to? Do you have time for one more question? Yeah, we do have one question.
Yeah,
but
let's
if-
continue.
Yeah.
Let's finish that. Yeah. Since
The next session is here, right?
yeah, it is going to be
Yeah.
here. And
So
Arjun
till they show up, we can keep going.
actually, they are outside. Arjun and Umesh, they are outside. They're coming.
Okay, so one last question, and maybe one person can address this. What are some good and poor examples of use of AI in the sustainability space? Any specific network or AI tools that are particularly useful?
I don't know. Now, there are lots of good or bad applications. Like I had a question for the previous AI person who talked about AI, and the question I had for him was, Punch, who happens to be the director for NSF, and a good friend of ours, also an IITian, he and I were having dinner at some place, and he was telling me, Ram, data anywhere is good data anywhere is good everywhere. I said, yes, Panch, I agree. But just like what Sundar said, AI, climate change, and even this data everywhere has that one severe risk of one rogue apple, which can actually destroy. That could very easily be a potential opportunity for misuse of AI. If I have 30 more seconds, I can share one more example. I have been going to Washington, D.C. on a regular basis for about 5 years, almost every week, discussing with EPA on policies. And these policies had to deal with risk management. When we had the Bhopal disaster, EPA came up with massive regulation. That's how it all happens. Agencies respond by a massive regulations, industry sues them, and then eventually you come to a balanced approach to this. And one suggestion that was made, and we were about 20 of us, 18 of them lawyers, and I'm the only non-lawyer there, another accountant was with me. And one lawyer from, believe it or not, EPA, I can't name who he is, he suggested we need to make these plans to address such disasters by keeping in communities informed. So I'm going to request that all the industries evaluate the most severe consequences and stick all those documents in high schools of every county. I said, have you ever heard of sabotage? I have never seen such silence in a group of 20 EPA folks. For the next 1 minute, nobody spoke. We have to consider those things. That's it.
Well, thank you. I think we have run out of time, and we did get to all the questions.
That was very insightful, as all the other sessions. I really want to thank all the panelists here, Praful, Ramesh, Marco, and Ram. Thank you for your time and your comments. Please